Hello everyone and welcome to the arcade. This is the third video in a series of videos detailing a scratch build of a zookeeper. In part 3 we will be creating toolpaths to cut by CNC. Alright everyone, welcome back to the third video in the series. This is where things finally start to get a little bit more interesting. So I have a couple disclaimers to go over first before we get started. The first one being is that I'm going to be using a 1/4 inch bit to be doing the cutting. I commonly get asked what my preference is for bits. It actually varies a bit depending on the type of wood that I'm cutting. But for melamine, my favorite is the Whiteside UD2102, the up-down 2102, which is this bit here. This is what we refer to as a compression bit, and if you look at it, it cuts two different directions. As the bit rotates, you'll see that it's pushing the wood cuttings down from the top side, and on the bottom side it's pushing it up. So as you can see, there's kind of an overlap in the middle there with it. So this is called a compression bit. Ideally, this is great because you can get really good finishes on the tops and the bottoms of your plywood that you're using, or in this case, melamine. Melamine chips really easy, and this is kind of the only bit that I've had a lot of good success with without having to tape out the melamine beforehand. For reference, the bit usually lasts for about 5 sheets for me, so I have to replace one of these bits every 5 sheets. Bits run about $32 or so off Amazon at the moment. My other note for before you actually start cutting your toolpaths is you need to pay attention to how thick your material is. I took a couple measurements from a few of the pieces of wood I have in the shop. My 3/4 inch plywood, construction grade, came in at 0.726. My finished plywood for furniture grade came in at 0.705. And my melamine came in at 0.772. Depending on the type of cabinet you're cutting, the thickness of the material may or may not matter. For a Konami type cabinet like a Ninja Turtles or a Simpsons, there is no overlap of the material, so you can cut it out of whatever material thickness you want. For a Williams style cabinet, or in this case a Taito cabinet with it, the construction being that there's dados causes you to need to know the thickness of your materials. Alright, time to get ready to start making some toolpaths. So before we get started, we need to take a few measurements from the drawings. As I said before, this is a dado construction on this cabinet, and as you can see, there's basically it's like a groove that's cut in for the panels to fit in. And if we look closer at, say, the front panel here, you'll see that there's this box on top of it. So the idea is that you're going to cut basically a pocket into this box, and this little groove here is then going to fit into the front of your cabinet. So what we need to know is how wide is these grooves. So if we zoom in and take some measurements here, we'll find that the distance across here is 0.3125 for the pocket. Alright, so we have our thickness now. And from here, the next thing we need to know is how deep does this cut really need to be. So if we go up here and look, we'll find that basically the tongue of this cut is going to be right at 1/4 inch. So what this means that there'll basically be about 1/4 inch of insertion of material into the side panels for our construction. Where this matters is as we start to cut our pockets, we'll have to know how deep we have to make these pockets. Alright, we're finally ready to start making our cuts. So the toolpaths as we set up, there's a strategy here. What you want to do is you want to take all of your inside cuts and your pocket cuts and whatnot. You need to cut all of those first before you actually cut out any of the material, meaning the actual cutout paths of your pieces. The reason for this is as you cut out your material and it's free, it'll then shift on you, and then your inside cuts may not be as accurate anymore. So the inside cuts for removing like the handles here and the inside of the coin door, I usually leave towards the end, and I usually try and do the things that I actually have to think about for the cuts first. So first off, from our measurements earlier, we said that the tongue depth for us had to be at 1/4 inch. So this is basically going to be this section here. And this is all one piece all the way around, which is nice, so you know everything fits nicely with it. So for us, I'm going to be cutting this actually at 0.3, which will give us basically 5/100ths of an extra inch for wiggle room, and it'll also help us a little bit because I will be putting glue in here as well. So basically I'm going to select this, go over to toolpaths, and I'm going to be cutting a pocket toolpath. And my pocket toolpath is going to have a depth of 0.3 inches. I'm going to be using an end mill, 1/4 inch with it. And this will be my pocket for dado. Okay, so there's my first toolpath. My next one that I have some concerns about will also be this one here. This is going to be the one, also a dado cut for the speaker panel at the top here, and this is going to be where the track slides in for the monitor glass and the bezel. So I'm going to be doing the same thing here as well. We'll just actually add this to the last one because I'm also going to be cutting it at 0.3. So we'll update that, and I'll have that listed now as well. All right, so the next one to worry about really is going to be these boxes. So for the front panel, there's going to be a dado that's going to be left behind, but the dado has to be of the correct thickness, which is going to be from our measurement earlier. The thickness here was 0.3125 inches with it. So for up top here, I'm going to basically be cutting pockets into the board for both of these, and the pockets based off my material thickness. So material thickness I measured at 0.772. The pocket, basically the width from the drawing, is at 0.3125, which basically leaves me at 0.446 inches of material I need to remove. I'm going to remove 1/2 inch just to have a little bit extra wiggle room for what's going on. So I'm going to make a new pocket here at 1/2 inch. And we'll call this pocket for front door, front panel. Okay, done. All right, so where to from here? I have a couple others as well that I need to be aware of. I have this piece here, which is basically going to be a holder for the monitor frame. I'm going to be also cutting a pocket here as well. Based on the video you saw previously in part 2, I already resized this piece, so I don't have to do anything with resizing. I just need to know how deep of a pocket. From my experience, I find usually I'm somewhere between 1/4 inch will hold very nicely. I can even go up to 1/2 of the material thickness as well. So here we will be making a new pocket, and we'll be doing it at 1/4 inch. And pocket for monitor frame, we'll save that. All right. And going back and looking what we have left to do here, we have this key that I talked a little bit also about in video 2. The key is really for placement, and I just really need to have a very, very slight pocket so I know where to put the key when I put it in place. So for me, I just really need to shave a small amount of material off, so I'm only going to be cutting it at a depth of 1/10 inch. I'll call it pocket for key. All right, and for other pockets that I have left, the last one I have is this one. This is for the back door. So the original Taito cabinet had a swinging door that mounted on the side with it. What I'm going to do is I'm going to basically put this piece on backwards with it and put a standard conventional door in the chair. So here I'm going to cut the pocket basically at 1/2 the depth of the material. And so I'm just going to do it at 0.4. All right, so pretty much all my pockets are cut, which is all the hard math things you have to think about. From here, it's basically I have to do either cutouts, either on the inside or the outside. So we'll do the sets of inside cutouts first. So I have the two handles on the back here, the inside of the coin door, and I'm actually going to do the holes for the coin door as well. And so what we're going to do here is now this time we're going to do a profile toolpath on it, and this is going to be for our inside cutouts. So in this case I'm cutting at a depth of 0.8, so I want to go through the material. As for my CNC setup, I have a spoil board as opposed to a vacuum table, which basically means that I can cut into the material or cut all the way through the material and have spoil board underneath to cut into as well. Basically the spoil board gets resurfaced after so many cuts so that it stays nice and flat. So for me, I'm going to be cutting this at a depth of 0.8, 1/4 inch end mill, and I'm going to be on the inside. And this is basically so that it cuts out and my my shape basically maintains the same shape. Now things to note here, and it doesn't really matter in this situation, but with the inside cuts that I have, my corners here are going to be partially rounded because I'm using a 1/4 inch end mill or a 1/4 inch router bit. And so I'm going to have basically a radius of 0.125 for all of these. And that's a limitation of the cutting. All right, so I have that set up, and so this will be my cut for insides. And now I get a warning saying I'm going to be cutting through the material. My material identified as 3/4 of an inch, and my maximum tool depth here is 0.8, which means I'll be cutting through the material. If I had a vacuum table, this would be really bad. Since I have a spoil board, this is perfectly fine. So I'll say okay to that. All right, and now pretty much what I have left is to cut out the rest of these. So basically you just select all of them. Go back to toolpaths, and I'm going to do a profile toolpath. I'm going to be cutting these out. In this case, I need to be cutting on the outside. If I cut on the inside, all of these would be basically a 1/4 of an inch too small, which is bad. And usually I name this as final cutout. And likewise, I get my warning here that I'm cutting at a depth of 0.8 when my material is only 3/4 of an inch thick, which is fine. All right, and now this pretty much looks like my drawing. So I'm in good shape. Now the last thing that I usually do here, and this is mainly because, as I said, I don't have a vacuum table, so I have a spoil board. So what I usually wind up doing is I mark spots where I can put drill holes, and basically what I do here is I cut little tiny thin holes in areas to help hold down the material. And usually I do this in areas where I'm concerned about the when I have to do pocket toolpaths to make sure that I'm held down as well as I possibly can be. So I'm basically just drawing these circles here, and this will make more sense once you see the actual cutting. But these circles are basically just marking holes where I'll be putting screws in. And the reason for this is that, as I mentioned earlier in the video, it's 30 some bucks for a bit. The easiest way to destroy a bit quickly is to hit one of the screws that's holding your material down. So what I'll do is I will mark these holes essentially for placement of my screws, and this way I can guarantee I won't have any toolpath collisions with my bit. So in this case I'm going to be doing pockets here as well. So pocket toolpath, I'm only going to make these 0.2 inches deep. They don't need to be deep. And I usually call this hole marker. So we'll calculate that out. And you can see they're all listed as well. All right, so the next thing we need to do, let me move this up. Next thing we need to do is start saving these toolpaths out for your CNC machine. So in my case, I save these as two separate toolpaths. My hole marker is the first toolpath that I save out. I save it out as a Mach 3, which is the program I'm running to actually drive my toolpath. So This is usually, I name these by date. In this case, I'll just call it Zookeeper Sheet 1. I usually identify which cut it is. So this is going to be cut 1, hole marker, and then I'm using a 0.25 inch bit. All right, and my second toolpath is going to be everything else. Now the order that you have these listed here is going to be the order that they're going to be cutting. And so as I said, my final cutout, where I'm cutting out these pieces as a whole, is usually last, or is always last. This way that it holds everything in place as I'm cutting the other parts earlier. Sheet 1. Save that. And now I'm pretty much ready to go. If I want to see what this looks like, I can simulate it as well. So I can basically preview all toolpaths, and this will go through and do a video or a representation of the bit moving around on the board so you can see what's going on. The previewing of the toolpath is really useful to make sure that you got all your cuts in order. When I first got started, I thought this was wonderful to watch, and I found that it helped me save a lot of sheets of material from making big mistakes. Once you get a systematic method for how you're going to be laying out your toolpaths, not as big of a deal anymore, and most of the time, honestly, I don't go through and view it, but still pretty cool to watch. I sped up this recording 8x to keep things moving. All right, so moving on to sheet 2. So the layout here is a little different than we left it in the part 2 video. I basically just shuffled things around a little bit to try and make it a little more efficient, so I'm not wasting as much wood. Wood's not as cheap as it used to be. So basically we're taking the same pockets and depths that we used on sheet 1 and applying them to the sheet as well. So we'll start out with the side panel. So as before, this pocket for the dado we had at 0.3 inches. So we set cut depth 0.3, 1/4 inch, and we'll label it pocket for dado. First cut path is done. We'll move on to, let's see here. This was for the support shelf for the monitor shelf. So we will make a new cut path here, also a pocket, and the last one we had it was at 1/4 inch. So pocket for monitor shelf. This one I skipped. This should have been part of this first one. So what you do is you wind up opening up your first cut that you had. And basically you just shift, click on it, add it to it, and then rerun the calculation. You'll get the same thickness out of it. So that's been added to our cuts. Next up is our key. And our key, as we said before, was just a depth of 1/10 of an inch. And the reason for this is just to mark the location of where the key gets placed. It's not really that structural in nature. All right, and now we need to kind of move on to the top here. So this one's a little bit odd. This is the top of the cabinet. What you'll find is we have to cut our pockets like we had before, like we did on the front, to basically create the dado. The problem we have here is twofold. So the first problem is that these get notched out on the end here, which is kind of hard to tell. There's another little box drawn here. Basically, this is a full cutout for the end. And then this slot here is basically where the marquee goes. But it's cut on the opposite side of what the dado cut is with it. So this we're going to leave alone, and we're just going to leave measure it and reference it for later, and we'll cut that on the table saw. So for here, let's remove our lettering so we don't select that by accident. And I don't need my hardware mounts. Oops. Don't need my hardware mounts. When I selected it, this was all one piece because it was grouped. So we're going to ungroup it. So these can be all interacted with individually. So I'm going to remove these because I don't need them. Likewise, I'll remove the lettering for the speaker panel. All right, so the next thing we had was that these pockets here, we cut the same as we did for our front panel. And so these were at a depth of 0.5. All right, so we got those marked. And then if we zoom in here, we see these little boxes. So these boxes are basically to allow for adjustment of the top panel to slide forward and backwards a bit. And so basically I'm just going to notch them out. So we're going to select that one, and there's another one here. So we'll select them both. And in this case, we're going to do a pocket of 0.8. Basically, I'm cutting out the whole piece. And so you're sitting there saying, well, why are you cutting out the whole piece as opposed to just running the cutout on it? What usually happens is in small pieces like this, if you have a little bit more width than the bit thickness, it's not uncommon for the centerpiece to jump on you. What I mean by this is as it cuts and gets freed, it'll spin, smack, hit the other pieces, may chip it, may jam it, may have other problems with it. So usually it's just easier to pocket it all the way to the bottom and don't have to worry about it. It gives us our warning we're going to be cutting through the material, which is fine. As I said previously, I have a spoil board, not a vacuum table. So we will do that, and so those are our deep cuts. All right, so that's pretty much it for this sheet. For this sheet here, well, let's look back. So these pockets that I just cut here, the two that are highlighted in pink, we also have over here. So we're going to highlight these also. Oops, let me ungroup it first. The grouping is really here just to make it easier to move stuff around. This way you can move an entire piece with all the additional layout stuff as one piece as you're trying to organize your sheet. So we're basically just adding these to the cuts that we had on this first side. So we'll recalculate those. Get our warning, which is fine. All right, and then we go back to our 2D view, and we still have to cut the holes for the speakers. Now, historically, I don't like to cut the mounting holes here unless I absolutely have to, just because there's always a chance that they're slightly off, which then causes problems. They're really easy enough to drill if you need to. So that's usually my preferred methodology. So select those for the speakers. Make another, and this one's kind of marginal whether you do a full pocket or whether you would cut out. In this case, I'm still going to do a pocket for the speakers. Probably be smarter to make my bit list last a little bit longer if I did these as cutouts, but for safety of the wood, I'll do these as a whole. Okay. And the thing I still have to do is cut these two slots here, which was the deeper pockets. Matches the same as what I did over here. So let me go back and find that previous one. You can see that it highlighted it correctly for me. So I'm just going to be selecting these and adding those to the same cut. So now I have all four selected, and recalculate the toolpath. And that's done as well. So pretty much I have all my pockets done, and all I have left is to cut out the full sheets. So as before, I set cut out as my last. So toolpaths cut out, and I'm going to be on the outside. I'm cutting at a depth of 0.8 with my 1/4 inch end mill. So label this as cut out. It'll tell me I'm going to cut through the material, which is fine. All right, so a couple little things I still need to do. I still need to mark this for my screw holes for holding the material down. So I'll do that next. As before, just kind of go around. Now in this case, I'm trying to save some of this material. So you'll find I'm going around the outside a bit more than I did before. And this is primarily just to try and minimize my scrap wastage of the project. Oops, that's a little too far off. So I got all my holes marked for my screws to be placed. So I will go through and do that. So basically just go through and select these. It's a little bit off, I'm going to move it. So as before, I'm going to make a small pocket here. 2/10 of an inch is fine, doesn't really matter. And there's my marker holes. Really the last part for me to do is I want to draw a small box here to save the piece of scrap material. That's still good for me. So basically all I'm doing is just drawing a vector line probably about there. And I don't necessarily have to overlap the edge of the material. Because this is melamine, it breaks real easy. So basically as the rest of this is screwed down, I'm just going to run this cut here and I can just give it a little wiggle and the piece will break right off. So for final toolpath here, in this case, I'm just going to cut on the toolpath, also 0.8, and this is just my scrap piece. All right, and that's pretty much it for toolpaths. Now, like I did before, you're going to wind up saving and exporting these out to Mach 3, which is the CNC controlling software for my machine. So we basically save these out as G-code. G-code is the language that the CNC reads, and it's specifically written for your controller or your software that you're using, so in this case Mach 3. So I'm going to export these out. Usually what I wind up doing is actually doing the exports directly on the CNC machine, but just for the purpose of the video I'll be doing it here. So save, Mach 3. I'm going to use my pocket. Nope, I need to do my hole marker I need to do first. Oops. So I'm going to just save the single tool path for my marked holes. Sheet 2, cut 1. And then everything else. Now I can have my scrap cut in here as well. It doesn't really matter. It just will be the last thing cut based off of, well, no it isn't. I have to move it down. Since it's at the bottom of the list now, it will be the last thing that's cut out for me. Save toolpath. And Zookeeper, sheet 2, cut out 0.25. All right, and that's it for the second sheet. All right, so we've made it to the final sheet. So sheet 3 is my plywood sheet, and this of course is also excluding the back door and that custom cut piece we need to do. at the base of the monitor glass. But this is just about the end here. So as I start out here, I wind up removing the text first, just cleans things up a bit. Now my problem here is that I honestly don't remember how deep these cuts are supposed to be. So I'm going to have to go back and look at the pictures on the website, which are there as a reference, and I'll insert that here. So looking at the pictures, it looks like that they are right at half of the depth of the material. So in this case, I'm going to be using my construction grade plywood. All right, so looking at my construction grade plywood, the original thickness was 0.726 inches. Divide that by 2, which will give me 0.363. So I'm going to make these 0.375, just overcut them slightly on it. These are all grouped together as well, so let me undo the groupings first. Groupings are undone. And let me just select these ends. So toolpath, pocket, my cut depth is going to be 0.375, 1/4 inch end mill, and we'll call this pockets for base. All right, let's see here. The power plug, or the power switch at the bottom, the air vent, and the inside here are all inside cuts. So I'm going to go up and select tool path for my profile. I'm going to cut it at 0.8 again. I could probably be a little bit less than that. We'll go with 0.78 because it's a little bit thinner material. 1/4 inch, and we're going to be cutting it on the inside so that the inside portion of this gets cut out. And as I said, we're going to have the radiuses, but for these cuts, it's not going to really matter for us. So calculate that. Warning that I'm going to cut through my material, which is fine. And then, let's see, how big are these holes? 0.251, so 1/4 inch. So I'm going to cut all of these holes as well. I have a Taito power supply. I'm debating whether I'll be using it for this project or not, but just in case, I'll cut the holes now. It just makes things a little bit easier. So in this case, I'm going to be cutting through the material, 0.78, select it at my 1/4 inch on the inside, and then these are mounting holes. All right, and that's pretty much it. So I just have my final cutouts, my pieces. Let me, how big is my gap here? 0.34, so I'll have enough room. So select all my pieces, toolpath, profile cut, 0.78, 1/4 inch. I'm going to be cutting on the outside this time. This is my cutout. Okay. And then likewise, as I've done with all my others, I also do my hole markers as well to hold the material in place. We'll make it 3/4 of an inch. All right, and that should do it. Now, the reason I'm putting the hole markers close to, well, it's a little too close, close to these is that the pockets need to be held down to the material. So what happens is that as you have different materials that you're working with, the materials tend to warp. They don't stay perfectly flat. And most of the time you honestly don't notice it unless you're doing CNC work. And so what happens is if you have a slight bend in the material, your cuts don't turn out, or your dado depths and whatnot all have problems with it. The nice thing with working with melamine is because it's totally manufactured, for lack of a better word, it is perfectly flat, which then does simplify the material as it usually sits flat. Plywood, historically, you'll find that once you go to the big box store and they cut the bands off it, if it's exposed to heat or sun or whatever else, tends to warp in the direction of the sun and doesn't sit flat anymore. So you need to be very careful when you're doing your hole markings that you try and get them close to your pockets so that it holds the material down flat so that you get a true accurate depth of how deep your router bit's cutting. All right, so we'll pocketize these as well. 0.2 is fine. And hole pockets. And we'll calculate that. And that's pretty much it. And like we did before, we'll wind up saving out the tool paths for your hole pockets and your other materials. All right, I think that covers tool paths in a nutshell. This is really crude and rudimentary, but hopefully you've learned something from this and is useful in understanding what's going on.